Hello everyone, learning Web3 and blockchain development can be divided into 4 parts. Number 1. I'll give you an overview of the industry. The use cases that you should know before starting actual development. How does Web3 even make money? And if it is a complete scam, or are there legitimate use cases? Number 2. We'll try to go through the complete syllabus of the Web3 course that will help you to get from 0 to 100. Number 3. I'll discuss a few project ideas. Some of these we'll be building in our upcoming videos, and some of these you can try to build yourself. Number 4. I will share free resources at the end that you can visit and explore by your own. Let's begin with a basic overview of the industry. If you ever want to join any industry, be it AI, Web3, or you know some other niche like SAP, the best thing you can do is build very ambitious projects. The way I define ambitious projects is the projects that are currently making money. A good example in AI might be either an LLM, or all the LLM-based libraries that exist, or all the application-level things that are happening. Basically, you can build any one of these if you understand how they're built. That's the best way to learn it, rather than following a curriculum top to head bottom or trying to learn it via courses or YouTube videos. When you're trying to learn Web3, the very first use case of Web3 is blockchains itself. I won't go too deep into what blockchains are. Well, blockchains are usually divided into 3 parts. You might have interacted with Ethereum, or have heard of Bitcoin, and these are called Layer 1 blockchains. These were the first ones that were introduced. They brought the concept of blockchains and decentralized money into the picture. These were there for a long time, but people realized it's really hard to build your own blockchain, and hence Layer 0 protocols were introduced. What does Layer 0 mean? It means it lets you build Layer 1 blockchains, and hence is called Layer 0. There are a bunch of other protocols that are called Layer 0 protocols. If there's ever something you can use across all Layer 1s, that's also sometimes labeled as Layer 0. But usually a Layer 0 protocol lets you build your own blockchain. So if you ever want to build, Bitcoin 2 or custom blockchain itself, then you use either Cosmos. People are still focusing on Layer 1. As I said, this is where most of the activity is usually happening. Transact either on Ethereum or on Solana. These are like top of the charts when it comes to decentralized exchange activities. Now Sui and Aptos are trying to do something similar to what Solana did and make the blockchain extremely fast and usable. Layer 2 took a different approach to scale Ethereum, or I can say that they took a different approach to scale old Layer 1, or you can say slow Layer 1. The way these scale usually is that they have their own blockchain, and you can transact there, but from time to time they roll up to Ethereum, and thus they put all the transactions, compress them somehow, and put it on Ethereum. So they get the security of Ethereum. They can technically be called highly decentralized, because they're rolling up to Ethereum, but they're really fast because they're a small blockchain. Let's talk about some end-user applications. The very first and most common use case is wallets. Believe it or not, wallets are one of the biggest use cases of cryptocurrency. No one thought they would be, but today they make a lot of money. Good examples here are Phantom, worth $1 billion, and MetaMask, valued at several $billion, at least its parent company. Why are they worth this much? Because they themselves make money. How do wallets make money? By earning swap fees. Throughout these slides, you'll see that most companies make money via swaps. A lot of people around the world currently own crypto, and whenever you own crypto, you often want to convert it. Most companies that make a lot of money do so by having a lot of liquidity and allowing people to swap these assets. Wallets are one such use case. If you ever try a swap in Phantom, you will see it says includes a Phantom fee, meaning if you make this transaction, you're paying a fee to Phantom. If you look at their wallet, you'll know this money finally goes to them. That's a lot of money, so that's use case number 1. And that's probably why they're worth $1 billion. Use case number 2 is decentralized exchanges. As mentioned earlier, wallets make money via swaps. The actual swapping logic is owned by a decentralized exchange, DEX. A decentralized exchange allows you to swap crypto assets directly from your own wallet. We'll discuss this in more detail in the cohort. But how do DEX make money? They also earn fees from swaps. Whenever you convert Ethereum to USDC, for instance, a fee goes to the decentralized exchange, facilitating the swap. Common DEX on Solana include Orca, Serum, and Raydium, while on Ethereum, Uniswap is a prominent example, with thousands of others now existing. These companies create smart contracts that enable swaps and provide front ends for them. Although you can build your own front ends, they also offer tools to add your own tokens, create your own swaps, and design a page for your own token. Use case number 3 is NFT marketplaces, which also generate significant revenue. OpenSea was worth over $1 billion during the last bull run and remains a popular marketplace on Ethereum today. How do they make money? Through swap fees. Every time you buy or sell an NFT, the platform facilitating the transaction earns money. For example, a bunch of CryptoPunks were recently sold, and each transaction generated revenue for the platform. On Solana, popular NFT marketplaces include Magic Eden and Solanart. Lastly, centralized exchanges are among the largest companies today, aside from the blockchain layer ones themselves. Exchanges are where most of the value has been accrued. Binance is the biggest, followed by Coinbase, CoinDTX, and Zepay in India. This is one of the best things you can build, to be honest, and it's where a lot of money is. Most ordinary people don't understand decentralized exchanges or wallets, which makes centralized exchanges an easy way for them to buy and sell crypto. This is a major motivation behind creating platforms like Backpack Exchange as well. If you're an ambitious team, this is an idea you should definitely pursue, as there's a lot of money to be made here. As more people buy crypto, exchanges are often their first entry point into the market, before they move on to decentralized exchanges and understand private keys. Initially, though, very few people do, which partly explains why Binance is worth billions and why Coinbase went public at billions of dollars. Let's go through the syllabus. It's likely to be very similar for the final cohort as well. It's project-driven, and I encourage you to attempt these projects yourself. Follow the syllabus format, build projects accordingly, and progress from there. Let's start with the initial section, Foundation, which covers the first 2 weeks. The reason for this is that many people may not be familiar with blockchain technology, including concepts like private and public keys. This section aims to bridge that knowledge gap. Even if you're not a coder, you'll grasp most of these concepts with a laptop and access to a terminal. Here's an overview of the topics we'll cover. 1. Understanding blockchains and decentralization. 2. Introduction to RPCs and their role in blockchain communication. 3. Common RPC methods and their applications. 4. Cryptography fundamentals and its relevance to blockchain security. 5. Gas transactions and their impact on blockchain operations. 6. The mechanics of public and private keys. 7. Creating and managing your own private keys. 8. Exploring derivation paths and their significance. 9. Introduction to tokens and non-fungible tokens, NFTs. 10. Basic cryptography techniques, including signing messages with private keys. 11. Differentiating between development and main environments. 12. Exploring airdrops and their function in token distribution. By the end of this section, each module will culminate in practical exercises. You should be able to create a wallet using a command line interface, manage private keys securely, execute transactions, and explore blockchain activities via an Explorer tool. After laying this groundwork, the subsequent focus shifts to understanding wallets and their functionalities. This is crucial for understanding public and private keys in a user-friendly context. We'll also explore how real-world users interact with and safeguard these keys. One of the highlights will be learning to connect to RPCs directly from a wallet and understanding various transaction types and queries. You'll gain insights into token balances, NFT holdings, and the interaction between wallets and the blockchain. We'll aim to build a multi-chain web-based wallet similar to existing platforms like MyTheWallet, but with additional features such as wallet impersonation. This functionality, though controversial in some contexts, will be a part of our learning to understand practical wallet operations. Moving forward, the focus will shift towards transactions. This phase is designed to deepen your understanding of blockchain operations through hands-on experience. You'll build tools like a portfolio tracker and transaction scanner akin to existing platforms like AssetDash. These projects will reinforce your knowledge of React as you develop user-friendly interfaces for blockchain interactions. The journey continues with decentralized exchanges, DEX, where you'll explore liquidity pools, automated market makers, AMMs, and the creation of custom tokens. The goal is to implement a swap feature on our platforms, similar to established DEX like Uniswap and SushiSwap. The subsequent phases will delve into smart contract development. Initially, we'll focus on Ethereum, where you'll learn Solidity, the primary language for Ethereum smart contracts. Topics will include syntax, smart contract creation, data models, and testing frameworks like Remix, Truffle, and Hardhat. Practical exercises will involve extending ERC standards, creating NFT contracts, and developing custom escrow contracts. You'll also explore existing smart contract libraries and learn how to integrate them into your projects. Following Ethereum, the syllabus pivots to Solana, introducing Rust programming for smart contracts. This phase will explore Solana's CLI, token program, and associated metadata handling. You'll gain proficiency in the PDA concepts and their role in data management on Solana. Projects will include building full-stack applications on Solana, implementing an ICO contract, and exploring indexing solutions for efficient data retrieval. The final segment will cover advanced topics like building exchanges or gambling platforms. These projects will incorporate secure transaction handling, user authentication, and integrating external wallets like MetaMask and Phantom. Throughout the course, free resources will be recommended for deeper learning. These include Alchemy's Solidity course, Solana's program library, and dedicated tutorials on Rust and Solana development. By the end of the syllabus, you'll have the skills to contribute to blockchain projects and understand the broader implications of blockchain technology in various industries.